Number 8, your savings account pays an APR of 5.6% compounded annually. If you deposit $1,200 at the end of each year for 8 years, what will the accumulated balance be in the account? Okay, so we're actually adding money constantly to this particular account. So here we do need the savings plan with regular payment formula. So I'm going to try to get them on the same screen so we can, well, yeah, I'll try that. Okay, so it's kind of tiny, but you can get the idea. Okay, so let's see. I want to know what the balance is after I make payments of $1,200. I got 1 plus 0.056. It's compounded yearly, so that'd be a 1 there. And 1 times 8 years minus 1. And divide that by our APR, 0.056 divided by 1. Okay, so that's what we want to type in our calculator. Now, because we are adding payments to this, we can actually go back up here, go to our future value, part of our spreadsheet in Excel. Or again, you're more than welcome to just type it in the calculator. That works too. And let's see, so we got 5.6 compounding periods. It compounds once a year. Present value, it's actually not worth anything at the start, but we are going to add 1,200 8 years in a row. And so now you're probably thinking, wait, this thing is negative, it should be positive. Let me go back up here, because really when I'm giving $1,200, I'm, again, if you mess up the negative, it doesn't matter because you're still going to get the same number, 11,707.77. Okay, and it actually matches what you get in the calculator if you took the time to type it in. All right, number 9, suppose you set up a new IRA that pays an APR of 7% compounded monthly. If you contribute $160 at the end of each month for 17 years, how much will the IRA have at that time? Okay, well that's actually, going back to our formula chart there, that's that savings plan because we're adding a consistent 160 a month, and now we're compounded monthly, so our N goes from being a 1 to a 12. Which is nice. Everything else is sort of the same. So I'm going to set up the formula for us so that if you want to type it in your calculator, you can. And then I'm going to go back to the Excel spreadsheet and just work out the answers from it. Okay, so the formula is going to be 160. 1 plus, what was our APR? 7%. So 0.07 compounded monthly, so divided by 12, raised to the 12 times 17. Let's see, so I'm going to close out minus 1 divided by 0.07 divided by 12. Okay. All right, so you're welcome to type that in a calculator. I'm going to go run to our Excel friend here. APR is 7%, compounded monthly. I didn't have anything in the account to start off with, so it's not worth anything. I'm going to add 160 at the end of each month, and there are 17 years. Okay, so if I do that, I should get 62,420.19. which is exactly what the calculator tells you if you got it typed in there correctly. All right, suppose you have 29 months in which to save for a $3,200 vacation cruise. If you can earn an interest rate of 4.8% compounded monthly, how much should you deposit at the end of each month? Okay, so let me look at our formula chart here. So in other words, we've got a time in mind. We've got an amount we want to end up with. What we want to know is the payment. So looking back at our formula chart, we're using this savings plan with regular payments, but we're actually solving for our payment. So let me set it up, and then we'll go to our Excel friend and see what it tells us to do. So I want 3,200 is my ending amount. I'm actually solving for the payment. So 1 plus 0.048 divided by 12, since it's compounded monthly. And I want to raise that to the 12 times, let's see, 29 months. Ooh, that's kind of tricky. So I want to convert that in terms of years. So 29 divided by 12, a lovely exponent there, minus 1, divided by, and then I have that APR over N, so the 0.048 divided by 12. Okay, so what I want to do then is I want to calculate all the stuff in the parentheses first, divide it by that 0.048 divided by 12, and then take that number divided by 3,200. Now, let's look at our Excel options here. Oops, that's not what I meant. Okay, is there something about a payment? Oh, look at that, right there. There is exactly a formula already set up for us in terms of calculating a payment. So we can totally use that. Or again, you're more than welcome to type it in the calculator. Let's see, so APR is 4.8. It's compounding 12 times a year, compounding monthly. Present value, it's not worth anything right now. That's what I want to set up money for. In the future, I want to have 3,200. And let's see, I want in terms of years, so 29 divided by 12. Uh-oh, it does not like that. Let me try something, because I think that if I put in like, yeah, that's what I thought. Okay, so let me do the 29 divided by 12 off to the side. So it's 2.42. Okay, so it likes that a little bit better. The way that this particular spreadsheet was constructed, it doesn't like fractions. But fractions are still fine. So according to this then, if we set aside $104.14 each month, we should have $3,200 set up at the end of the 29 months. And again, that does match what the calculator gave us as well. All right, number 11, we're given a student loan of $8,000 with an APR of 6% for 8 years. Find the monthly payment. I am just going to go to our Excel friend. And let's just type in our parameters. See if I can get this all in on the screen. Oh, I can almost get it all in, sort of. Okay, anyways, doesn't matter. APR of 6%. Okay, so 6% compounded student loan. Okay, so because it's a student loan payment, we're going to have to make a payment each month, so it's going to be compounded monthly. Student loan of 8,000. So its present value is worth 8,000. future value, I want it down to nothing. And I want to make payments on it for 8 years. Okay, so our monthly payment should be $105.13. Okay, so part B is asking the total amount paid on the loan. Well, the way this question is set up, you have to get part A right to get part B. You know, it's sort of a progressive question. In other words, they're building towards an overall point here. Well, let's see. So if we did 105 each month, so that's times 12 times 8. So then I would be able to figure out how much I physically paid for the entire life of the loan. And so that tells me that I paid $10,091.52. Part C, the total percent that went towards the principal. Okay, so if I paid $8,000 or $10,000 and the principal part was $8,000, so what percent of my loan would have been that? So that's the 8,000 divided by the 10,091.52. And that gets me 0.793. So 79.3% went to the principal, and the interest has got to be the other part of my loan. So I know that that's 1 minus 0.793, because those two parts have to add up to 1. Sorry, I'm going to get my eraser to fix this. Okay, so 0.793. And I get 0.207, so 20.7% went to interest. Calculate the monthly payments for a home mortgage of $74,000, fixed APR of 5.2% for 30 years. Okay, so the nice part is we can go back to our little Excel friend, and we can just update the parameters and type that in. So let's see, present value is 74,000, so it's negative 74,000, because that's money I don't have that I owe. 5.2% APR. So it's compounded, so it's gonna, once a month we've got to make a payment. We got to do that for 30 years. Okay. There we go. Okay. So calculate the monthly payment. So $406.34 is what we're paying each month. So monthly 406.34, and then calculate the total amount paid for the house. So that's not, so in other words, I borrowed money. I'm not paying 74,000. I'm paying actually a lot more than that. So if I take the 406.34 times 12 times the 30 years, 406.34 times 12 times 30. So we're getting 146,282, and that's actually about right for a house. Okay, number 13. Suppose you take out an auto loan for $14,000. Determine your monthly payments. Hey, let's go back to our Excel friend. And let's just update the numbers. So 14,000. APR 6.5. And 4 years. All right, so monthly payment is $332.01. All right, suppose you have a balance of $4,300 on your credit card, charges APR 15%. Assume no additional expenses to the card, and you want to pay it off in 1 year of monthly payments. What is the total amount of interest you'll be paying? Okay. Let's see. So what we need to figure out is what our payment will be. And again, we seem to be going back to the same. Oh, here we go. Loan payment formula. So here's our payment formula that we can use. Let me get it side by side so I can write out the formula in case you want to type it in your calculator. All right, so okay, so our payment is the principal, the 4,300 times 0.15 over 12, 1 minus 1 plus 0.15 over 12 raised to the negative 12 times 1, because we want to pay this off in 1 year. Alright, so that will tell me what my payment is for each month, and then I can work backwards from there to figure out what the total interest is. So again, you're more than welcome to type that into calculator, or we can just pull out our Excel friend here. And our Excel friend has actually got a new thing I'm going to show you, but it'll tell us what the payment is. Okay, so 15%. Compounding is 12. Future value is negative 43. Present value is negative 4,300. Future value is 0, and I want to get that done in a year. So that's going to be 388.11. Okay, so then, make this bigger. To figure out the amount of interest, I want to take that 388.11 and I want to multiply that by 12. So that's really how much money I'm paying. So 465. Okay, so 4,657.32. That's what we were paying on that. So the amount of interest is going to be to take that number and subtract. So that actually gives us, 357.32 in interest. And that works, assuming you can get past the calculator. I realized I didn't close out my parentheses. So if we can get past the calculator part, it's not too bad. Now, let me kind of go back to our Excel friend here. And we actually have a built-in debt interest right there. So if we can type in our parameters, then it will tell us how much we are paying in our debt interest. So, see if I can slide this over. Okay, so our interest was 15%, 12 compounding periods, original number of payments was going to be 12, so we're going to pay it off in a year. Present value was 4,300. 100, and again 1 year. And so the amount of interest we earn is 357.33, which is about what we figured out. So, yay.